For centuries, humans have been fascinated by the world around them. We've asked questions like, what is matter made of? How do different substances interact? This thirst for knowledge led to the birth of chemistry. Chemistry is the study of matter and its properties as well as how matter changes. Early chemists, often called alchemists, pursued magical goals like turning lead into gold. While they didn't succeed, their experiments laid the groundwork for modern chemistry. Today, chemistry plays a vital role in our daily lives. From the food we eat to the clothes we wear, chemistry is everywhere. Understanding chemistry starts with grasping its fundamental concepts. We need to explore the building blocks of matter, the language of chemistry, and the principles governing chemical transformations. This journey into the realm of chemistry promises to be an exciting one, full of fascinating discoveries and awe-inspiring revelations. Let's embark on this journey together. Imagine the smallest thing you can possibly think of. Now imagine something even smaller than that. You're getting close to the realm of atoms. Atoms are the fundamental building blocks of all matter in the universe. Atoms are incredibly tiny. Millions of atoms could fit on the period at the end of this sentence. Despite their minuscule size, atoms are incredibly important. They are responsible for the properties of everything we see, touch, and interact with. But what exactly are atoms made of? Atoms themselves are composed of even tinier particles called protons, neutrons, and electrons. These subatomic particles are constantly in motion. Protons and neutrons reside in the atom's nucleus, its central core. Electrons, much smaller than protons and neutrons, orbit the nucleus at incredibly high speeds. The number of protons, neutrons, and electrons in an atom determines its properties and how it interacts with other atoms. Atoms are social creatures. They rarely exist in isolation. Instead, they like to combine with other atoms to form larger structures called molecules. A molecule is formed when two or more atoms bond together. These bonds are like tiny, invisible links that hold atoms together. The type and strength of these bonds determine the properties of the resulting molecule. For example, a molecule of water, H2O, is formed when two hydrogen atoms bond with one oxygen atom. This simple combination of atoms creates a substance essential for all life on Earth. Molecules can be as simple as two atoms or incredibly complex, containing thousands of atoms arranged in intricate structures. The diversity of molecules in the universe is astounding. From the air we breathe to the DNA that carries our genetic information, molecules are the building blocks of the world around us. Understanding how atoms bond to form molecules is crucial to understanding the properties and behavior of matter. Imagine walking into a library with millions of books, but no organization system. Finding the book you need would be nearly impossible. That's where the periodic table comes in for chemists. It's our library for organizing the elements. The periodic table is a chart that organizes all the known elements in the universe. Elements are the simplest pure substances, each made up of only one type of atom. The periodic table isn't just a random arrangement of elements. It's carefully structured based on the properties of each element. Elements are arranged in rows and columns based on their atomic number, which is the number of protons in an atom's nucleus. This arrangement reveals patterns in the element's properties, making it a powerful tool for chemists. By understanding the periodic table, chemists can predict how elements will behave and interact with each other. It's a fundamental tool for anyone studying or working with chemistry. Section 5. Decoding the elements. A look at the periodic table's structure. The periodic table's structure provides valuable insights into the elements. Elements in the same column, called a group, share similar chemical properties. For example, the alkali metals located in group 1 are all highly reactive metals. Rows on the periodic table are called periods. Elements in the same period have the same number of electron shells. Electron shells are regions around the nucleus where electrons are likely to be found. As you move across a period, elements gradually transition from metals to nonmetals. The periodic table is color-coded to highlight different categories of elements. Metals, located on the left side and center of the table, are typically shiny, malleable, and good conductors of heat and electricity. Nonmetals, located on the right side of the table, generally lack these properties. The periodic table is a dynamic tool, constantly evolving as new elements are discovered. It's a testament to the ingenuity of chemists and their quest to understand the building blocks of the universe. Section 6. Chemical reactions, the dance of atoms and molecules. Chemistry is not a static subject. It's all about change and transformation. Chemical reactions are the heart of chemistry. They occur when atoms and molecules rearrange themselves, breaking and forming new bonds in the process. Imagine a group of dancers changing partners during a dance. That's similar to what happens during a chemical reaction. Atoms are constantly in motion, colliding with each other. When conditions are right, these collisions can cause bonds to break and new bonds to form, resulting in the creation of new molecules. Chemical reactions are happening all around us all the time. They're the reason we can breathe, the reason food gives us energy, and the reason plants can convert sunlight into chemical energy. Understanding chemical reactions allows us to control and manipulate matter, leading to countless applications in medicine, agriculture, manufacturing, and many other fields. Section 7. Types of chemical reactions from combustion to photosynthesis. Chemical reactions are incredibly diverse. They can be as simple as the rusting of iron or as complex as the biochemical reactions that sustain life. Chemists classify chemical reactions into different types based on the changes that occur. One common type is combustion, where a substance reacts rapidly with oxygen, releasing energy in the form of heat and light. Think of a burning candle or a roaring fire. Another important type is photosynthesis, where plants use sunlight, water, and carbon dioxide to create glucose, a type of sugar that stores energy. Other types of reactions include synthesis reactions, where two or more substances combine to form a new substance, and decomposition reactions, where a single compound breaks down into two or more simpler substances. Each type of chemical reaction plays a crucial role in the natural world and in countless industrial processes. By understanding the different types of chemical reactions, we can better understand the world around us and develop new technologies to solve global challenges. Section 8. Chemistry in Action, Real-World Applications. Chemistry is not just an abstract science confined to laboratories. It's an integral part of our daily lives. From the moment we wake up to the time we go to sleep, we're surrounded by the wonders of chemistry. Consider the food we eat. Cooking is essentially a series of chemical reactions that transform raw ingredients into delicious meals. Baking a cake involves the reaction of baking soda with acidic ingredients, producing carbon dioxide bubbles that make the cake rise. Medicine is another field that relies heavily on chemistry. The development of new drugs and therapies wouldn't be possible without a deep understanding of chemical principles. From painkillers to antibiotics, chemistry plays a vital role in keeping us healthy. Chemistry is also essential for protecting our environment. Chemists develop new technologies to clean up pollution, reduce greenhouse gas emissions, and develop sustainable energy sources. Section 9. Conclusion Chemistry, the Central Science. Chemistry is often called the central science because it bridges the gap between physics and biology. Understanding chemistry is crucial for making sense of the world around us, from the smallest atom to the largest galaxy. By grasping the fundamental concepts of chemistry, we unlock a deeper understanding of the natural world. We begin to appreciate the intricate ways in which atoms and molecules interact to create the diversity and complexity of life. Chemistry is a constantly evolving field, full of exciting discoveries and endless possibilities. As we continue to explore the mysteries of matter, we can look forward to new technologies, groundbreaking discoveries, and a deeper understanding of our place in the universe.